Hello everyone, this video is a continuation of my previous video about object highlighting in OpenGL. I hope with this video we need no more discussions about object highlighting in OpenGL. Let's first take a look at the overview of this video so you know what you can expect from this video. First, I want to correct some typos in the previous video. Then I want to show you a failing case of the usual approach in the Learn OpenGL repo. Next, I'm going to review the proposed method in the previous video and explain the simplified version. Then I will show a demo of the simplified version of object highlighting. And finally, I want to show you the code. This is a slide from the previous video. There is a typo inside. So in the final step, we overwrite 0 zones instead of non-zero zones. As you can see in the last image, so only the 0 zones, I mean the black area is overwritten by the highlighted colors. That's it. Now I want to show you the demo of the Learn OpenGL repo. I created a fork of that repo in my own GitHub account, and there is a branch called Object Highlighting V1. And in this video, I'm going to show you V1 and V2. First, let's look at the V1. Instead of looking at the V1, first I want to show you the original stencil testing of that repo. So this is the demo in the book of Learn OpenGL. As you can see, there are some borders around the objects. When you zoom in, the border is very thick. When you zoom out, the borders become thinner. As I mentioned in my previous video, if the anchor node of the object is not the geometry center, then the highlighted area cannot fully cover the objects. So let me prove that. I created another file of the stencil testing. There's no much difference here. I just offset the cube a little bit. But you can see this is the vertex of the cube. So the vertices of the cube is symmetric about the origin of the coordinate system. What I'm doing here is offset the cube, so the anchor node of the geometry is at one of its corner. Let's run the demo. As you can see, the highlighted area does not fully cover the objects, and also some parts of the borders are very thick, and others become thinner. And also when you zoom in, this becomes horrible. So in this video, I want to show you a different version. Let me compile. So this is the simplified version. As you can see, the border becomes more consistent. And also when you zoom in, zoom out, the border is the same. Let's go back to the presentation. First, let's review the method in the previous video. In the previous video, there are 4 render targets, which is a bit complicated. So first, we render target A, which is the main render target. So we first render other objects. So forget about this car here. This is the final image. So when we actually rendering the image, first we draw some other objects. Then we render the selected object here with the stencil buffer enabled. And remember that is very important. Then we render another target B only with the selected object with a constant color. And then we have a target C. In target C, we dilate the object of target B. Then we blend target C and target A. Then we get a target D. After that, we draw target D upon target A. And this time we apply a mask of stencil buffer, so only 0 zones is overwritten. And finally, we can get this image. This is what we want. So if you look at the whole pipeline, it's a bit complicated. So I want to show you a simplified version. Just think for a while, what are we really doing when talking about object highlighting? Go back to this slide. What we are doing here is very simple. We enable the stencil buffer of target A, then we draw a enlarger the area of this object, right? If we can directly change the stencil buffer of this object, we can make this a lot simplified. Just think about it. So what we really want is a enlarged stencil buffer of this object. So in the previous video, I said it's not possible to directly modify the stencil buffer. Yeah, that is somewhat true, but we have a workaround, bleed frame buffers. With this trick, we can significantly simplify the method. And only 2 render targets are required. Let's look at the diagrams below. The first row is the user approach, and the second row is the simplified version I propose here. First, we render other objects which look at this star. Then, compared to the first row, we render the selected object in another target, which is render target 1. Then in target 2, we dilate the rendered object a little bit, and also we enable the stencil buffer. So this is the color buffer of render target 2, and this is the stencil buffer of render target 2, right? And here, the magic happens. Let's look at the second row. First, we render normal objects like the star here, which is the same as the first row. And this is the render target 1. Next, we render this object. Okay, let me repeat. In the second row, we first render normal objects in the default frame buffer. That is the first diagram here. Then we render the selected object in render target 1, which is this image. This is render target 1. Then we dilate this object a little bit. This is the render target 2, and with render target 2, we enable the stencil buffer. And this is the stencil buffer of render target 2. And here comes the magic. We bleed the stencil buffer of render target 2 to the default frame buffer. And we also bleed the color buffer of render target 2 to the default frame buffer. You see? But this time, we only render colors. We only overwrite because of the stencil buffer. We only enable overwrite at non-zero zones, which means only this circle is bleed to this image here. You see? And next, we continue the normal rendering. We render the original selected object here. In this way, we get a simplified version of object highlighting. What is improved? Yeah, it's very apparent. We need less render target, so the render pipeline is clear and easy to understand. What is more important is that this method does not change the order of rendering. We just add a few steps between the original render pipeline. What does that mean? If you look at the second row, first we render the normal objects, then we add some pre-processing here, then we continue render the original object. So in this way, we don't change the order of rendering. We just insert some steps in the between. The demo of the simplified version I have just showed. Let me show you again. You see? This is my repository of Learn OpenGL. You can take a look. So here are two branches. The version 1 is the failing case, and the version 2 is the successful case. Now let me walk you through the code. It's very simple. First, we define a simple render target. It always has a step stencil buffer and a color buffer. And here we create a function to create a render targets. And here we also offset the cube, so we are not cheating here. And here we create two render targets, render target A and target B. The name is different. The target A is the render target 1 in my slides. Target B is render target 2 in my slides. So let's look at the main rendering pipeline. So here it selects on uniforms, then it draws the normal objects, which is the floor. As I said in my slides, now we render the selected object to target A. So we bind the frame buffer of target A, we clear the buffer, we do some normal rendering, but with the highlighted color only. Now we render to target 2, which is target B here. We bind the frame buffer, the same, we clear the depth buffer, color buffer. And here we set the radius of the dilation, which is 5. You can increase a little bit if you want a thicker border. I don't want to go to the details of this. We bleed the stencil buffer of target B to the default frame buffer. Now we bind to the default frame buffer, and here we bleed the objects only when the stencil buffer is non-zero, it's 1. Then we disable the stencil buffer and continue our normal rendering, which renders the normal objects. And that's it. Very simple, right? Now I've showed the code. That's the end of this video. Thanks for watching.